Okay, here we go. So everything you could wish to know about advanced trigonometry. This was the next one in the vote that we did a while ago. And boy, this is gonna be a big topic. This has potential to go on for quite some time. Just so you're aware. So maybe chunk this one up into a few little bits because we're gonna go deep into this topic. Okay, we're gonna do a little bit of everything. So, first thing we know, or we need to know for advanced trigonometry, is the formulas. Okay, there are three of them. Two of them can be written in different ways, but I tend to write them one way and remember that I can use them a different way. There's the sine rule. Okay, the sine rule involves your sines, and it can be written sine A, capital A, over little a, is sine B over little b, is sine capital C over little c. You may see this written the other way round. You may see it as little a over sine A equals little b over sine B equals little c over sine C. Okay? And these two things, you may use them for different scenarios. I would use this one for finding angles. Because the angles are at the top, it means I've got less rearranging to do. And I would use this one for finding sides, okay? Because the sides are at the top, and there's less rearranging to do. Remember, this is all going on from a triangle which is not right-angled, okay? If we've got our angles capitals, the lowercase letters go in their opposite pairs. So capital A and lowercase a are opposite each other. Capital B and lowercase b are opposite each other. Capital C and lowercase c are opposite each other as well. That's our first rule. That's the sine rule. We also have the cosine rule. Now, lots of people will write this in two different ways, like with the sine rule, depending on whether you're finding a side or an angle. I don't. I don't do that. I remember it one way because the formula is complicated enough as it is. It's a squared equals b squared plus c squared, which is a little bit like Pythagoras' theorem, then minus 2bc times cos capital A. Okay, that times in there is important. That is something that some people sometimes miss. Sometimes people do. Okay, gotta remember that times, okay? If I'm wanting to find an angle for this, I would still use this formula, but I would do a little bit of rearranging, and I'm going to show you that later on in the video. And then there's a third and final one, which is the area using sine. Okay, and this one is just a half AB and then sine capital C. Now, each of these formulas has their own conditions as to when or where we would use them. Okay, and we're going to take a look at them one at a time. Okay, we're going to do the sine rule, then the cosine rule, and then the area using sine. Okay. And remember, this is all to do with non-right-angled triangles. These will work for right-angled triangles as well, but it's a little bit overkill. Remember, for right-angled triangles, you can just use your normal SOHCAHTOA. Okay, for this, these will do anything, but right-angled triangles, it's a bit overkill. We would rather use this with non-right-angled triangles. Okay, so let's take a look at our sine rule. So, for the case of the sine rule, we need to know when we can use it and what we can work out. Okay, for sine rule to be able to work, what we need are pairs of information. Okay. Now, with the triangle that we've got here, it doesn't look like I've got any pairs. Okay. But with it being a triangle, we can work out what this third angle here would be. This third angle here would just be 180 take away 84 take away 40, because degrees in a triangle add up to 180, right? So we would have one pair of information here. Okay. Now, if we were trying to find out any of the other two sides, that would be either this one or this one. And then suddenly we would have a second pair of information, or even a third pair of information. Okay, so in this triangle, I would be able to work out anything through using the sine rule. Okay, and the way that we would do that is by setting out our sine rule using the formula we saw on the previous slide, plugging the information in, and then doing a slight amount of rearranging to get our final answer. Okay? So just for a case and example, let's say that we wanted to find out what x was. Okay? So I had these pairs of information. I was trying to find out what is the side x. Okay? Now with the sine rule, I want to put what I'm finding at the top. I want my sides at the top. Okay? So let's say that was A. That would be capital A. And then for my other pair, this would have to be capital B, and this would be lowercase b. So with my sides at the top, I'm going to have x over sine 84 equals 8 over sine. Now we need to work out what that angle is. 180 take away 84 take away 40 is 56. Now, what you can do is you could work out what this right-hand side is, but I'm not going to, because I'm going to try and keep my answer as accurate as possible. If I want to work out what x is here, I'm going to have to get rid of this fraction part here. Now, if I want to get rid of that fraction part, I need to do the opposite of dividing by sine 84. I've got a times by sine 84 on both sides. So x would equal 8 divided by sine 56 times by sine 84. And we would work that on our calculator. We would do 8 divided by sine 56 times by sine 84. And on your calculator, you should get that equal to 9.597 for 3 decimal places. Okay? And that's how we would work out its sides. We would make it so that our sides are at the top, do a little bit of rearranging, and away we go. We're done. With angles, we do pretty much the same thing, only we use the other version of the sine rule, which is this one, but reciprocated. We've flipped everything upside down. Okay? So I'm going to do the one on the left, and I'm going to leave you to have a go at the one on the right. There's our reciprocated version of the sine rule. It's the one that we used before, just flipped over. Do I have pairs of information? Always good to check if you've got the information that you need. We've got one pair here. That looks good to me. And we've got another pair there, and including the thing that we want to work out. So let's call this capital A. This would be lowercase a, which means that this would be capital B. That would be lowercase b. Let's stick our stuff in. So we've got sine capital A, which is what we're trying to work out, over 7, opposite pair, is sine 47, that's the capital B, divided by 6. Now, just like before, we want to try and find what this capital A is. Okay, and we need to do the opposite of dividing by 7, which is to times by 7. Sine A is going to be sine 47 divided by 6 times by 7. Now, do make sure that you close your brackets when you're typing things into your calculator. Always good to close your brackets. Okay. Now, this gives me 0.8532 ... Now, that angle there is not 0.8532 ... It's not. It just isn't. Look at it. It's not. We need to know what this capital A is. And the way that we do that is by using the inverse function of sine. Okay? Capital A will be sine inverse of 0.8532 ... Okay? Remember we said we use the sine minus 1 when we're working out what those angles are going to be. Now we call that sine inverse, now that we've done our inverse functions. That's going to be 58.57 degrees, 2 decimal places. Now that angle does look a bit better, like 58.57 degrees. Okay, that's much more like what we're after. Right, I'm going to give you a chance to pause the video here and try out the one on the right-hand side. Give it a go, give it a whirl, and when I'm going to give you a little countdown, and then I'm going to go through it myself. So you have got 5 seconds to pause the video. 4, 3, 2, 1. And a bonus second or 2. Right. Hopefully you've had a go at that question, okay, and not just let me continue as if I'm kind of your background noise, okay? I ain't your Netflix. We need to label up our triangles. So this is the bit of information I want. I have my opposite pairs, which is good. That's going to be my capital A. Going to be my lowercase a. Going to be my capital B. My lowercase b. Now, for this one, angles at the tops, because we're working out what our angles are, just like before. So sine capital A over 6.5 equals sine 74 over 8.2. Remember, working in our pairs. Just like before, we get the sine A by itself, and we do that by multiplying by the denominator. We end up with sine 74 divided by 8.2 times by 6.5. And then just like before, I could work that out on my calculator. And then I'm going to do A is sine inverse of all of this stuff. Okay. And when I do that on my calculator, so I'm going to do, you could type it all into your calculator if you wanted to. So you could type in sine inverse of sine 74 divided by 8.2 times by 6.5 and then close the brackets. Oh, I got my brackets in the wrong place. There we go. To give us an accurate answer of 49.64 to 2 decimal places. And it said work out the missing acute angles, and there we have. We have worked out our acute angles. Perfect. If it ever asked you to work out an obtuse angle, to work out your obtuse angle, we would add 90 degrees. Okay? So this one would be 139.64. And the reason for that is to do with the graph of sine. Okay? Our graph of sine does... Oh, gosh, I only just had enough space there. Looks a bit like this. Okay? Now, let's say that we got our 49.64 degrees, which is there. Ooh, let's put a cross instead. The next time we would be that level would be over here. Okay? This distance, 90 degrees apart. Okay? So just so that you know. Right. So let's move on. Editing me is taking a little bit of a step in here. When the me that did this recorded this initially before I watched it back and made sure everything was okay, it was quite late at night, and what he just said here is absolute nonsense. Okay, so they're not going to be 90 degrees apart. I don't know what he was thinking when he said that, but it's not going to be 90 degrees apart. Okay, you can ignore that. In fact, all of that's rubbish. Okay, what it is going to be, I'm going to do this in red pen now so that you can see it, so that, past Mr. Hughes gets exactly what he deserves, is that this distance here, that's 49.64 degrees. Okay, this distance here is also going to be 49.64 degrees. To get your obtuse angle, you would do 180, take away the 49.64 degrees. Okay, editing Mr. Hughes is correcting the real life Mr. Hughes that did this at this point. The red is what you want. The red is true. Okay. Okay. Ignore previous me. Okay. The red is the truth. Okay. Yeah. Whew. It's a good job I watched these back, eh? Anyway, I'm going to hand over back to real me now. And, well, past me, I suppose. And then I'm going to let him talk you through the cosine rule and hope he doesn't make any more mistakes, silly Mr. Hughes. Alright, so now we're going to move on to the cosine rule. So the cosine rule is the one that potentially has the most awkward formula to work with, okay? And I would generally use it in the form that it's given to me here, okay? This form. Okay. This is the form that we would use for working out sides because it's just equal to this. If I'm working out an angle, I would substitute stuff in, like we'll see in a minute, and then rearrange to get the capital A. Okay. Now, it's important that we set up our triangle with the letters properly, okay? The capital A is the angle that we want to use, okay? What we're looking for in this is we're looking for a corner of information. Okay, we've got two sides and that angle. We have a full corner of information. This stuff is going to be our B, our C, and our capital A. Okay, so that's going to be our B, our C, and our capital A, which means this side over here is going to be our lowercase a. Okay. So let's just tidy things up. We are after corners of information. Right, there we go. So let's tidy things up a little bit. This is our B, this is our C, this is our capital A. That's our lowercase a. What I would do is I would literally just plug everything into the formula. So a squared is, I nearly wrote the formula out again. I don't need to, it's written up there. A squared is 9 squared plus 7 squared. Take away 2 times 9 times 7 times cos 37. And I would just, because we're working out what this thing is, I know what all the numbers are here. I would literally just type that into my calculator. 9 squared plus 7 squared times 2 times 9 times 7 times cos 37. Boom. A squared equals 29.372 for 3 decimal places. Now, one thing to bear in mind, that is not the side length here. It is the A squared. That is the side length squared. Okay, we will need to do the square root of that number to get us our answer. I do that. My calculator gives me 5.42, but 2 decimal places. Remember, if you're midway through a question, don't round too much. Okay, if you round too much, you'll get an inaccurate answer. Okay? Don't round too much. Now, for the cosine rule, that is pretty much it in terms of finding lengths and finding sides. Okay, you just got to make sure that you set up your triangle in the right way with your capital letters and lowercase letters and things like that. Okay, we're going to give you a little countdown again to try the one on the right. So we're going to give it a 5 and a 4 and a 3 and a 2 and a 1. Okay, so hopefully you've had a go at that question at the right-hand side, and if you haven't, you should be hitting pause now, because you need to be giving it a go. Give it a go. Okay. We set out our triangle just like we did before, so the angle is the capital, which means that this is our lowercase. We have our corner of information, that's what we need, so we've got our B and our C, and it doesn't matter which way round those two things go. You could do it so the C goes at the top and the B goes at the bottom. It makes 0 difference, okay? And then we plug things into the cosine rule. So a squared is b squared plus c squared minus 2bc cos a. Remember, all of those things have got multiplications between them. All of those things have got multiplications between them. So a squared is 12 squared plus 7 squared minus 2 times 12 times 7 times cos 62. Okay, so here we go. I'm just going to type all of that into my calculator because I can. 2 times 12 times 7 times cos 62, close brackets, equals a squared equals 114.129 for 3 decimal places. Don't forget that final step. A is the square root of 114.129. So I can just do the root of my answer on my calculator, which gives me 10.68 for 2 decimal places. Boom. Done. Okay. So there we go. There's our cosine rule. But we haven't taken a look at the cosine rule yet, where we're looking to find an angle. Okay. Now, I said I would use the same formula. Some people would write the formula out differently. Personally, I don't see the point. Okay, why would you make it harder for yourself and try and remember 2 formulas when 1 formula will do the job just as good? Okay. There's our formula. Don't forget, all of those things have got multiplications between them. Now, we're trying to find out what this angle here is. I'm just going to make sure that we can't use the sine rule for this. Now, we've got a pair of information here, but no other pairs. And we've got no other angles as well, which means we can't use the sine rule, because remember, the sine rule would need pairs of information. We would need 2 pairs of information. This one, I've only got this corner that I'm working with. Okay, even though this angle is unknown, we're still working with that corner. Okay. Now, the capital letter is the angle that I'm after. I'm after that angle there, which makes this lowercase a, and these the b and the c, and it doesn't matter what order they go in. So we plug things in. 8 squared equals 7 squared plus 6 squared minus 2 times 7 times 6 times cos capital A. Now, this time we've got to be a little bit more careful about what we work out. 8 squared is 64. 7 squared is 49. 6 squared is 36. That's fair enough. take away 2 times 7, which is 14. 14 times 6 is 84. Excuse me 1 second. Sorry about that. I just needed to cough. Now, we can work some of this out. Be careful. I have to do the 49 plus 36 separate to the 84, okay? I cannot do 49 plus 36 take away 84. Things will go wrong, okay? This bit must be done separate to this bit, okay? They are two separate things, okay? So 64 would equal 49 plus 36, which is 85 minus 84 cos A. Now, rearranging our equations, we are trying to get the cos A by itself. I'm going to have to take away the 85 from both sides before I can undo the multiplication by 84. 64 take away 85 is negative 21. Negative 21 equals negative 84 cos A. That minus sign has not disappeared. That's something else to watch out for. That minus sign does not disappear. We are then going to divide by, not 84, we're going to divide by negative 84. The wrong time of day for doing this. There we go. So we're going to have negative 21 over negative 84 equals cos A. You notice that I've not worked this out. I've not stuck that into my calculator. There's a reason. Now, if you remember back to our sine rule stuff, when we got to this stage, we would use the inverse function to get the angle by itself. We're going to do that to this. So we're going to use cos inverse, cos minus 1, of this is equal to A. And that's why I've not worked out what that fraction is. It's so I can type it into my calculator and get an exact answer straight away. The exact answer I'm getting is 75.522 for 3 decimal places. Okay. Always check to make sure what degree of accuracy the question needs you to give, whether it's 3 significant figures, 2 decimal places, or whatever. Right, this video is already 30 minutes long, but we've still got one more aspect of advanced trigonometry to go. This is a huge topic to do in one video. Okay, but this is everything you could possibly want to know about advanced trigonometry. The last thing that we have is how to work out the area of a triangle involving sine. Okay, and the easiest way to do this for me is to show you some distinct examples. Okay, I'm going to do the first one, and I'm going to leave you to do the other 2. Okay, first thing to note, what do we need? We need a corner of information. Just like we had with the cosine rule. Okay. Now, the formula is 1/2 AB sine C. So we do need to be careful with what letter we use for our angle, because the letter that we've got here is the capital C. So the angle is going to be capital C, which would make that lowercase c. And then the 2 sides that we've got left over are the A and the B. And just like with the cosine rule, it doesn't matter which is the A and which is the B. Okay, it's our freedom of choice. So our area would be equal to 1/2 of AB sine C. Remember, if you've got things squooshed together like we've got here, they are timesed together. So that's going to be 1/2 of 9 times 12 times sine 111. Calculator jobby. So 1/2 times 9 times 12 times sine 111 is 50.413 to 3 decimal places. Boom. Done. Of course, they could, just, what's the word I'm after? They could just try to change it around and say, we know what the area is. Can we work out some other stuff? Which I would just use the same formula, plug the information in that I know, work out what I can, and then do a little bit of rearranging to find my final answer. Okay? Just like we did with the cosine rule. So, plug it in, work out what you can, rearrange, done. Okay? So I'm going to leave you with B and C to have a go at yourself, and then I will come back to you when I've given a little countdown. You stop, so you're going up 5, 4, 3, 2, 1, and you should have hit pause by now. I mean, you really should have hit pause. It's not hard. Okay, you tap the screen and everything, or if you're in a computer, you just hit pause. But anyway, we're after some answers at this point. Why is he wittering on? Give me the answers. Okay, I will. Got our formula. Capital C for our angle. A and B are the other two sides. So this one is going to be 1/2 of 5 times 7 times sine 40. Happy is Larry. 1/2 times 5 times 7. That's 1.5. Mr. Hughes, what are you doing? Times sine 40. There we go. The area of this triangle is 11.25 to 2 decimal places. And the last one over here, we've got 1/2 of 11 times 8 times sine 35. Which is 0.5 times 11 times 8 times sine 35. 25.24 to 2 decimal places. There we go. Bada boom. Done. Okay. Now, in recent memory, what I can remember from sine rule, cosine rule, and stuff like that within the GCSE higher syllabus is that they are normally asked within some degree of problem solving. Okay, because what they're looking to do with this is to challenge those grades of 7 to 9. Okay, and basic uses, I would say, you're looking at your grade 7. It's complicated. Formulas to remember are generally quite awkward, but if putting it together, it's not too bad. You just plug things in and away you go. The problem-solving aspect of it, though, does develop a whole new level to this. Okay, so we're going to take a look at one problem-solving question where we're going to have to figure stuff out as we go. Okay, and then I think the video will be long enough by that point. Alrighty, so this is the kind of thing where you would have to be careful, you would have to be observant to try and get everything that you would need. Now, I reckon that on a GCSE scenario, these bits here might not even be there. Okay, and it would just say, find the area of triangle ABD. Okay. And with that, you would start to think, okay, or hopefully start to think, okay, area of a triangle. It's a non-right angled triangle, which means that I got to be using my area of a triangle using sine. Okay. Area is 1/2 AB sine C. Now, I don't have any angles. In fact, I've only got one side. That's this one here. Okay. And if we remember, the area of a triangle uses corners. Corners of info. So if this is one thing that we've got here. I either want to know what this side is and this side is with this angle, or know what this side is and this side is with this angle. Okay? And we would need to make a decision on which one we're going to go for. Okay? So we've got two choices. We can either find out the red corner, or we can work out the blue corner. I'll give you a moment to decide for yourself which one you think you should choose. Now, if you said to yourself the blue corner, I've got news for you. You're making your life difficult. Okay, you're really making your life difficult. Okay, the red corner is going to be much easier for us because it's closer to the triangle where we've got more information. Okay, so that's going to make things a lot easier for us on the long term. Okay. So what we're going to do is we're going to scrap the blue corner. We're going to work with the red corner. Okay. Now we need to know two things. We need to know the angle here, which is going to be much easier. And we're going to need to know the side up here. Okay, which is going to be a little bit more difficult. Okay. So let's find x first. Let's find that side. Now, let's have a look together at this diagram and see what have we got, what can we do. Okay, so I want you to take a look and to see and to tell me what have you got, or to tell yourself what have you got. Now, if you said to yourself, we've got pairs of information here, I would say to you, you are very observant. Well done. We've got this pair here, and we've got this pair here. And if you remember your pairs of information, that means you're using the sine rule. And we're using the sine rule to find a side. So we're going to have sides on top. Pair up. So we're going to have sine 48 underneath. Equals 6 over sine 50. Okay, we know what to do with this. We times by the denominator to get rid of the fraction. So x would be equal to 6 over sine 50 times sine 48. Happy days. Type that into our calculator, we get an answer. So sine 6 divided by sine 50 times by sine 48 equals 5.821 for 3 decimal places. Happy days. We've worked out what x is. Now we also need to work out what this angle is. The purple for me. Now, fortunately for us, angles in triangles always add up to 180 degrees. So we can work out what the double angle is. Okay, angle DBC is going to be 180, take away 50, take away 48. Okay, 180, take away 50, take away 48 is 82. Now, unfortunately, what with this being a question that targets that 7 to 9 area, it's unlikely that you would get a mark for working this out. You might, if the paper is being generous and lucky. It's always worth writing down, but you might not get a mark for it just by itself. Okay. Angle ABD being 180 take away 82. Okay, that we might get a mark for, because it's then putting two bits of information together. Okay, so this is 98 degrees. Finishing this question off then, to find the area of this triangle ABD, we would use 1/2 of 8 times 5.821 times sine of 98 degrees. Okay. 1/2 of 8 times 5.821 times sine 98, close brackets, 23.06 to 2 decimal places. And that would be centimeters squared because we have been given a unit. And speaking of units, there is this absolute unit of a topic, okay? I will confess, there is a little bit more to this topic which you could look at, which I would mainly focus on within looking at the trig graphs. But as far as advanced trigonometry goes, I would say that this is probably the bulk of the stuff that you would need to know. Okay? Know your formulas, know which way round to write your equations to make it easier for yourself, and look at your problems carefully to figure out what your answers are going to be. Okay? I'm going to sign this video off at wow, 40 minutes. Jeez Louise, that's long enough. All right. And I'll catch you in the next one. Bye, guys.